Okay, so this is chapter 18, the figure and graph analysis chapter in my book, Overcoming Digital SAT Math. As usual, if you have a copy of this already, attempt to do the problems by yourself first and corrections by yourself first to get the best results, and then come back to this video for anything you're stuck on. So let's get started. Also, you can go to my ACT video, which I'll link in the description, or I might decide to make a whole separate video and link it there about a whole lesson on all this stuff. So just be on the lookout for that. And let's get started. So for number 1, it says, an alternative rock band sold a lot of tickets to their various concerts over the years. The graph above shows the amount of tickets sold each year for a certain period of time. How many tickets did they sell in 1977? So 1977, let's look where that corresponds to. It corresponds to 12.5. Now be careful because it says tickets sold in thousands. So it's not 12.5 tickets, it's 12.5 times 1,000 tickets. So 12.5 times 1,000 is going to be C, 12,500. So now let's go to this one right here. Whoops. Number 2. An alternative rock band sold a lot of tickets during their various concerts over the years. So same sort of thing, but the question's different. How many tickets did they not sell before 1980? So be careful with these. You would not believe how many students answer these types of problems wrong, even when they bold and or capitalize all of those letters. So we want to know how many tickets did they not sell before 1980. So these are going to be the tickets that they sold before 1980. So then this part represents the tickets that they did not sell before 1980. So we have to figure out how much this all is. So this lines up with the 10. This lines up with the 25. And this lines up with 22.5, like halfway between the 20 and 25. So we're going to add all those up, but then remember it's in thousands, so then we have to multiply by 1,000. So if we add all of this up, that's going to be 57.5. 57.5, and then we're going to multiply by 1,000. So then that's going to move the decimal over by 3. So then it's going to be 57,500 as the answer. So now this question number 3 is referring to the same scenario up here, but the question's different. What is the mean amount of tickets sold in thousands of tickets for 1975 to 1982? So we want to find the mean sold in thousands of tickets. That's important as well. So I'm going to erase all this. Well, actually, I should have kept some of those numbers, but we'll just do it all over again. So mean is adding up all of these numbers and then dividing by the number of years that we're talking about here. So here it's going to be 10, here it's going to be 20, here it's going to be lining up with 12.5, here it lines up with 5, here it lines up with 7.5, here it lines up with 10, here it's going to line up with 25, and here lines up with 22.5. Now, it says it's in thousands, and they want the answer in thousands, so I don't have to do that whole thing where I'm multiplying by 1,000 here because of that, because those match. So all I have to do to find the mean is just add these numbers up. So add these up in your calculator, and then you divide by how many numbers you add up or how many years we're talking about, however you want to think about it. So there's 1, 2, 3, 4, 5, 6, 7, 8. So you would add these up and then divide by 8. And when you do that, you're going to get 14.06 as your answer. So let's now go to this question right here. So we have these bar graphs. So the graph above, thank you guys for sharing the live and liking the live. The graph above summarizes the expenses of 3 different companies, Company A, Company B, and Company C in 2015. According to the graph, which company had the lowest combined office and travel expenses in 2015? So office expenses is the dark colored one, and then travel is the gray bar. So we want to have, when we're adding up those bars, we want to get the lowest number possible for the company that would correspond to this answer, that answers this question. So let's see what we have here. So 12 plus 9, and even though it says in millions of dollars, I mean, that doesn't matter if we're just always comparing in millions. You can decide to like write it in millions if you want, but that's kind of just a waste of time. So then this would be 7 and 7, and this would be 10, and that's going to be 3. So if we add these up, we get 13 for company C, we get 14 for company B, and we get 21 for company A. So the one that's the least is going to be company C. So the answer would be C right here. So now we're talking about the same figure up here. And it says, according to the graph, which company had the lowest office expenses? So we're just looking at office, so just the black bar, the lowest one. And that would be company B. So it would be answer choice B for that one. Okay, let's keep going. So we're going to use this bar graph to answer the next two questions. So employees at an animal shelter decide to track the average weight of different types of animals that they care for at the shelter. Based on the graph above, the average weight of a guinea pig, so this guy, is what fraction of the average weight of a cat, this guy. So guinea pig, you'll see it's halfway between the 0 and the 5, so it's going to be 2.5 pounds. The cat is 10 pounds. So if we write that as a fraction, it's going to be 2.5 over 10. So the decimal is going to move 1 to the left. You could also do this in your calculator if you don't know that rule. Just like do 2.5 divided by 10. And then you're going to get 0.25 as your answer. You could have also written this in fraction form as 1/4. Same thing. So now, here's another way that they might ask this, just kind of like in a backwards way. So it's referring to the same figure. And it says, based on the graph above, the average weight of a dog is how many times the average weight of a cat? So, average weight of a dog, you'll see it's like not exactly halfway. It's just a little bit under. So, let's guesstimate that that's, I don't know, like right before you get to 27.5. So let's say like that's 27. So let's guesstimate that that's 27 because it said something, I think it was closest was the wording. Pick the best estimate. So 27 for the dog, and then the cat is 10. So how many times the cat to get to the dog? So that would be, let's see, what's the best answer choice? The best answer choice would be C, 2.7. Okay, so now let's go to this one right here. Oh my gosh, my hand is getting a cramp from holding that steady. Okay. So now we're doing this one. It's showing the savings rate, and then we have the years here, amount in savings there, in thousands of dollars. Be very careful on the exam. They love to trick you with like scale of, like how they're doing the scale on each axis, and also like the units. Like you'll see this is in thousands of dollars, not just dollars. So let's see, we're referring to that one. Ava and Alex both tracked the average amount of money they saved for several years as displayed in the figure above. Which statement best describes the general trend in savings rates for Ava and Alex from 1993 to 2005? So let's see, it's trying to determine like increasing, decreasing, so let's see how they go. So this is always increasing. This one's increasing, still increasing, still increasing, still increasing. So they both increase the entire time, so it's going to be answer choice D. Please like and share this live, guys. It really helps out, and you can share it with any of your friends that are doing like SAT or ACT prep. This will help with both. It just happens to be my digital ACT book that I'm doing. So use the box plot below to answer questions 9 through 14. So What's the median? Now, these questions are not in like the typical format. It's just really good review of several topics really fast with box plots. So median is going to be the little line in the middle of the box plot. Well, I shouldn't say middle, inside the box plot. So where does that line go to? The 6. So the median is 6. Now, the minimum value is the end of the left tail right here. So that's going to be 2. The maximum value is the opposite. It's the end of the right tail right over here. So that's going to be 8. And then we have the range. So there's range and there's interquartile range. Range is this right here, from the max to the min value. Max minus min. So that distance between is going to be 6. So that's the range. Now, interquartile range is different. Interquartile range is the length of this box, basically. So this is going to halfway between the 6 and the 8. So that's at 7. So it's going to be 7 minus 4. So then that's going to be 3. And then now we're going to go to number 14. Which of the following is true about the box plot shown above? So let's see, can we do yeah, it'll show the question at the same time. Okay, so the median is greater than the mean. So what I like to tell students is associate the bigger portion of the box with the mean. So like this is the bigger portion of the box, so associate that with the mean. And then we know that this line is the median. So the median is further up on the positive end of the number line, like towards the bigger numbers, than the mean is. So the median is in fact greater than the mean in this case. So that's correct. Now let's go to number 2. The upper quartile is smaller than the lower quartile. So upper quartile is this guy right here. Let me erase this right there. Okay. Upper quartile is this guy. Lower quartile is this guy. So the upper quartile is in fact smaller than the lower quartile, so that matches. Now let's talk about skew. So with skew, also I tell students pay attention to the mean, or the bigger portion of the box. So like if it's negatively skewed, the bigger portion of the box is towards this side of the number line. If it were positively skewed, it would have a bigger portion of the box right over here towards the right. Which it does not, so it's not positively skewed. So it would only be 1 and 2, so it would be B. Okay, so let's go to, this box plot is going to be for the next couple of problems. So for median, it's going to be the little line again. So we have to figure out where that is on the number. It's not exactly at 2. It looks like it could be at 2.5. So that would be B. And then for number 16, which of the following could be the minimum value? Remember, minimum value is this guy right here. So that looks halfway between 0 and 2, so 1. And let me just erase this right there and that. Okay. So now let's go to number 17. Which of the following could be the maximum value? So maximum value is this guy right here, which is halfway between 8 and 10. So that's going to be 9. And what is the range? Remember, range is from the max minus the min value. So basically the length of the entire thing, like from here all the way to there. So from 9 to 1. 9 minus 1 is 8. So that's the range. Now, interquartile range is the length of this box part. It's a different thing. So it's going to be from 2 to 6, or you could think 6 minus 2, and that has a length of 4. Thank you guys so much for liking the live. Please like and share it to help spread it to other people. So now let's go to number 20. Number 20. Which of the following is true about the box plot shown above? So we'll go back and forth. So the median is greater than the mean. So remember I said in the previous problem, think of the mean as like the bigger portion of the box. So in this case, the median, which is this line, is less than the mean. So median is less than the mean, so it's not greater, so it can't be that one. That's wrong. So the next thing we're checking for is the upper quartile is smaller than the lower quartile. Now, upper quartile is this guy right here, like the right whisker, I think is the term. And then the lower quartile is this guy. So upper quartile is bigger than the lower quartile. So that does not correspond with what number 2 is saying. That has to be wrong then. So then now we're going to go and check number 3. The box plot has a positive skew. Again, pay attention to where the bigger portion of the box is. It's, if you think of a number line, like the bigger portion of the box is going towards the positive end of the number line. Like there's more of this portion of the box towards the positive. I'm trying to think of another way to say that, but I can't think of one right now. So it's going to have a positive skew. Like if more of the box, like if this portion of the box, the bigger part of the box was over here, it would have a negative skew, but it's not. So it has a positive skew. So it does in fact have a positive skew. Whoopsies. So that is correct. Number 3 only. Whoops, I cannot circle. It's hard to do that at the same time as like holding the phone and everything. Okay, so let's go to this one right here. So I tried to include like stuff that could possibly like trick people up, like every possible thing you could see. And this is one that a lot of students are not used to because they're used to seeing like the whiskers, right? So let's do this one. Which of the following is true about the box plot shown above? Maximum is equal to the upper quartile. So think about when we were talking about like upper and lower quartiles, like those were the whiskers. Like upper quartile was like the right whisker, lower quartile was the left whisker. So one is saying the maximum is equal to the upper quartile, and that tracks because if the maximum is equal to the upper quartile, you don't have to like extend it out. You don't need that that whisker, that upper hand, right hand side whisker. So that tracks. And then the same logic can be applied to the other side. The minimum is equal to the lower quartile, so you don't need to like extend it out. Like it's just equal, so there's nothing that needs to go on the left-hand side. So that tracks as well. And it says the median is less than 2. That does not track because the median is exactly at 2. So it would just be 1 and 2, C. Okay, so now let's go to this one. Which of the following must be true regarding the box plot shown above? So it says the minimum is equal to the lower quartile. So just like how we said before, if that were true, then there would be like no left-hand whisker right here, which we have one, so that doesn't track. That's not true. Number 2 says the maximum is equal to the upper quartile. So here, that tracks, that is true. Like, we don't see any whisker up on this side. So that tracks. The median is greater than 5. That tracks as well, because like halfway between 4 and 6 would be 5 right here, and it's a little bit above that. So it's going to be 2 and 3 only, D. So now let's try 23. So it says, based on the box, okay, so which ones are true? The median is 2. This line is the median. It's right at 2, so that tracks. The maximum, and also just as a side note, if you had to rush and guess on the exam, like you would just cross out C at this point if you figured that out really fast, and then you've like helped your chances a bit more than if you were guessing between all 4. Process of elimination. The maximum is equal to the upper quartile. So the maximum is equal to the upper quartile. That is not true because we see there's a whisker on this side. If that were true, there would not be this whisker portion right here. So that's not true. The minimum is equal to the lower quartile. That is true because we don't see that whisker out over here. So it's just 1 and 3, D. Whoops. Let me erase that. Okay, so now we're comparing this data set, these two data sets, data set A and data set B, and we want to figure out what's true. So it says data set B's median, remember the line in the box is the median, is less than data set A's median. Well, yeah, that's true. It's definitely less because it's like at 6 and this one is at like maybe 7-ish. So it has to be A. So let's go and do this one. For the box plot shown above, which of the following must be true? Dataset B has a lesser range than dataset A. So remember, range is, if it's just regular range, it's the length from one end to the other. So this basically is the range of dataset B, and this is the range of dataset A. So dataset B does in fact have a lesser range than dataset A, so that tracks. Thank you guys for the likes. Okay, so let's keep going. Dataset A has a greater median. Remember, this line right here is the median. Has a greater median than dataset B. That tracks, because this is like past 5, and this is going to be probably like around 2.5-ish. So that tracks. So dataset A's minimum, this guy, is lesser than dataset B's maximum, which is this guy. So yes, that is in fact true. So let's go to this one right here. For the box plot above, if Q is the median of dataset B, R is the median of dataset A. So let's start labeling this so that it's more helpful. So Q is the median of dataset B. So this line thing right there inside the box is Q. And R is the median of dataset A. So this line right here is going to be R. And S could be the mean of either dataset. Then which of the following is most likely true? Okay, well, let's start by comparing, well, actually, it's not going to help us eliminate, oh, it might help us eliminate answers. Yeah, because it switches it up a little bit. We can eliminate some of the answer choices by just comparing Q and R. So Q has to be less than R. So Q is less than R here, Q is less than R here. Q is greater than R there, so that doesn't work. Q is greater than R there, so that doesn't work. So now you just have to determine, is it A or B? So S could be the mean of either data set. So the mean is usually represented by like this right here, this box portion. So it would be it would be answer choice A, because it can't be equal to it. Equal to the, what do you call them? The medians. It would be like, well, it would be most likely that it's in between and not exact, like it would be not likely that it's equal to Q and R, like it's equal to the medians. It's probably going to be in between if you think about like the mean being the bigger box portion for each of them. So then let's go to number 27. What is the mean of the data set shown above? So this is, what do you call those? Dot plots, I think is what the name is. So each of these dots is kind of like, with those, it's kind of like those frequency tables. It tells you how many times you have that number or that data point in your set of data points. So like one dot at 35 means this. It means I have 35 one time in my list of data. And like one dot at 40 means I have this. And then 3 dots at 45 means I have this, and then so on and so forth. So if we're going to visualize it, it would look, woo, that's supposed to be 65, like this. So to find mean is just going to be the sum of all your data or your entire list basically, divided by the number of data points. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. So what you would do is just add these up and then divide by 11. So when you do that, you're going to get 51.42 as your mean. And then for number 28, what's the median of the data set? So median's just the middle value when you line them up in order, which I've already lined them up in order. But if you hadn't already, like you would have to think about it in order, like visualize it some way in order. So you're trying to find the middle value. It's also easy to see, like, just, you don't even need the list. You can do it just by looking at the dots, because you can say, oh, if I circle this guy, there's going to be 5 on this side and 5 on this side, so this guy's in the middle. So that's the median, 50. But you can use it and do it like the list way if you prefer that way. It's just going to take you longer. And then what is the range of the data set shown above? So that's going to be the max minus the min. So it's going to be 65 minus 35. So 65 minus 35 is equal to 30. And what is the mode for the data set? So that's the number that shows up the most frequently on the list. Or you can think of it as like the one with the most dots. So it would be 45. And then we're going to, hold on, let's see. Yeah, I can get it in the picture. Okay. So if another dot was plotted at 60, which of the following would change? So instead of this, it's saying, hey, we're going to add, and I'll do like a open dot right there to show that it's different. So we had all these solid dots, right, as part of our dot plot, but we're adding that extra point at 60. And we want to know which of the following would change. So let's see. Well, right away you can see there's no longer a mode of 45, because look, 60 has the same amount. So that's changing. So it has to be 1. Because it goes from like 51 point something to 47.083333. So it does change. And then the median is just going to be the middle value. So initially our median was 50, but if we're thinking, oh, we're going to add another 60 over here, then we're going to have an even number list. So then it's going to be between these two values as our middle value. So then we have to add up 50 plus 55 divide by 2. So then it's 52.5. So median does change. And then we have to determine, does the range change? No, because the highest max value is still 65, lowest is still 35. So then we have to subtract 65 minus 35, still get 30. So that does not change, so it's just A. Okay, so let's keep going to number 32. Four different stores are selling a new type of smartphone. In order to promote the smartphone's launch, each store is discounting the smartphone by a different amount the first week of its release. For 4 different stores, a reporter plotted the sale price of each smartphone and how much each store spends procuring each smartphone. For which of the 4 stores was the total profit per smartphone the greatest? So which store does it have the greatest profit, basically? Okay, so we would do like sales price, like what they're selling it for minus how much it costs to like get it would give you the profit. So basically like the Y minus the X needs to be the greatest. So let's find the difference between those for each of these. So this is right at the 10. This looks like it's halfway between 50 and 40. So 45 minus 10. So this would be like 35 as the profit. And then let's do the same thing for B. So that looks like it's a little bit beyond 65, like, I don't know, let's say 67. 67 minus, this is halfway between at 20 and 30, so at 25. So we would have 67 minus 25, and that's going to equal 42. So that's already in the, like, winning this profit race, I guess. And then this one's going to be, that looks a little bit above halfway of the 55 mark. So let's say that's like, I don't know, 56. Minus, and then this is at 40, so that is going to be like 26, so B is still winning. And then we have 80 minus 50, which is going to be 30, so B definitely wins. And then which of the following most likely approximates the ratio of the smartphone sale price to the procurement cost for store C? Okay. Oops. So ratio of the sale price to the procurement cost for store C. So we're looking at this. Let me erase this. We're looking at this value right here. And then the sales price would be about like 56. And then the procurement cost is exactly 40. So if we do a ratio of the sale price to the procurement cost, it would look like this. Now, remember, ratios you can kind of think of as like the same thing as a fraction. Like you could pretend like this is 56 over 40. The same rules would apply for simplifying it, where you find the greatest common factor. So I'm going to divide by 8 on top and bottom, and I'm going to get 7/5, which is the same thing as 7.5. Like the same rules apply, like whether it's dot dot or fraction bar for simplifying. So it's going to be A. Okay, let me just check that my key is right. 1 second, guys. B, A, yeah, good. Okay, I'm like scared that I made a typo after that last one. Okay, so let's go to 34 through 36, and that's all referring to this situation right here. So Elizabeth decides to ride her bike to visit a hiking trail. She starts her commute by leaving her home and traveling in the direction of the hiking trail. Her distance from home is represented as a function of time in the graph below, where y is equal to d of t, and d is the distance from home in miles, and t is the number of minutes since she left home. Okay, so after biking for some time, Elizabeth decides to take a snack break before continuing her commute to the hiking trail. For which of the following time intervals did Elizabeth take a snack break? Okay, so remember, this is the distance and this is the time. So if she's taking a snack break, like she stopped, she's not biking anymore, like she's not continuing to travel a certain distance, like her distance shouldn't be going up or down or anything like that. So where is that happening? That would be right here, where it's just all leveled off, like it doesn't go above 20, it doesn't go below 20, like it's just all staying at 20. So now we have to ask ourselves, okay, what does that line up with? What lines up with here and here? Each of these boxes is going up by 5, so between 5 and 10 minutes, B. So now, let's see, sometime after her snack break, Elizabeth realizes that her bracelet has fallen off and turns around to search for it before continuing her commute to the hiking trail. For which of the following time intervals did Elizabeth turn around and search for her bracelet? So remember, this is the distance from, was it her house or school or something? Distance from her house. So like this is the distance from her house that she's traveling. So if she's going back to find the bracelet, then her distance from her house, like she's getting closer to her house, so her distance from her house is decreasing, right? So let's see, where is that happening? So the distance would be decreasing right over here. It also decreases right over here, but this part, like how do I say this? So like this portion right here, you see how it goes up afterwards? So she continued to travel to the hiking trail after this portion. This is most likely when she's going home, because she's because her distance just is strictly decreasing. Like she's getting closer and closer to her home. So this is probably like the ride back, you know? So it's this guy right here. So that's from the 15 to the 20 minute mark, C. Okay, so we're going to go back and look at it after we read 36. On which of the following intervals is Elizabeth's distance from home strictly decreasing, then increasing? So let's erase all of this. So decreasing, then increasing. So here it's decreasing, and then here it's increasing. So it's going to be from this portion to this portion. So that's from 15 to 30. So that would be C. Okay, let me just check really quick. Yep, okay. Now let's go to 37. So we have motorcycle A, this is the speed, this is the gas mileage. The graph shown above displays the mileage for motorcycle A at various speeds. How many gallons of gas are required to drive motorcycle A for 4 hours at a constant speed of 20 miles per hour? So the speed is 20 miles per hour, and we want to know, the gallons of gas. So we're trying to find gallons of gas. So remember, gas mileage is given in miles per gallon. So if we can figure out how many miles they're going to travel, then we could figure out how many gallons using that relationship right there. So 20 miles per hour, and they're traveling for 4 hours. So hours and hours cancel, so that would be 80 miles, right? 80 miles. And then let's see, at the 20 mark, the gas mileage would be right here, so that's 30 miles per gallon. So then we would have 30 miles for every 1 gallon, so miles and miles cancel out to just leave us with how many gallons. So it would be 80 over 30 gallons, which you could just cancel out the zeros and make it 8/3. So that's your answer. Okay, so let's go to the next one. So it says that we have like this figure that we're referring to above, and approximately how many minutes after ceasing to exercise did males and females have the same heart rate recovery? So let's see, heart rate recovery, and then males and females. So we want it to be the same heart rate recovery. So they have to be meeting right here. And then we have to see what time does that align with, like how many minutes after exercising. So that would be a little bit before 2.5. So let's go with whichever one says that, which would be A. Oops. Okay. So now we're referring to this figure up here. And it says, school faculty for 3 different high schools estimated how many students would attend the annual school dance this year, and compared this number to the actual number of students who attended the annual school dance. For which high schools did the school faculty overestimate student attendance? So the gray bar for each of the schools is the how many students actually showed up in hundreds, and then the black bar is how many students were estimated to show up in hundreds. So if they overestimated, then that means that the black bar should be greater, like representing a greater value, which it does that for each of these. So it would be all the schools, 1, 2, and 3. So that would be D. So now let's refer to this figure. For the line graph above, the line graph above shows the average temperature in Miami, Florida for 2022. Based on the graph, the temperature in November was approximately what percentage of the temperature in May? So November is right here, and then May is going to be right there. So let's see, that's going to be lining up with 81. Whoops. And then this one is lining up with 87. So we're going to have 81 over 87 times 100. So then that's going to be, hold on, let me calculate it. 93.103 yada yada yada, so approximately 93%. Okay. So on the digital SAT exam, they're starting to like these types of questions more, like the stuff with the scatter plots and best fit lines, or like you'll see an example later where it just has like the dots and not the best fit line, and you have to like kind of like guess an equation for it. Like those sorts of things are becoming more popular, so just watch out for that. So it says the scatter plot above shows 9 values from a data set. A line of best fit for the data is also shown. Which of the following is the best interpretation of the y-coordinate of the y-intercept of the line of best fit? So we're interpreting this point right here, which is at 9. The y is 9 there, and x is 0. So 0, 9. So which of these corresponds to that information? So that would be x is 0, y is 9, so D. So let's keep going to number 42. Which of the following graphs best represents a strong positive association between H and T, where H values are along the vertical axis and T values are along the horizontal axis? Okay, so positive association is going to be like this way, like basically as close as you could get to a positive, like your typical positive slope line. Is a strong positive association. The opposite, like this one, would be a strong negative association. This one's a strong positive association. So you want the dots to kind of form one of those patterns. In this case, this pattern for strong positive association. So that's going to be answer choice A. Okay, so now for number 43. We're using this for the next two questions. So the scatter plot below shows the relationship between X and the number of hours a student studies, Y and the test score they receive. A line of best fit is also included in the scatter plot below. Sanem studied for 10 hours for her math test. Based on the line of best fit, what is Sanem's predicted test score in percent? So this is important, based on the line of best fit. So they're not asking for the actual data point, they're just asking for, based off of this gray line right here, the line of best fit, what's her predicted test score. So at 10 hours, we're looking at this point right here, which corresponds to 80%. So it would be B. Which of the following is most likely the correct equation for the line of best fit? So let's look. Line of best fit, it's a line, so linear equation y equals mx plus b. The y-intercept is 55. So positive 55 has to be the y-intercept. So I can automatically cross out a and b. And now I just have to determine the slope. Well, you could calculate the slope if you want, but I see right away that C and D, like C has a negative slope and D has a positive slope. This is a positive slope. This line has a positive slope. So it's going to definitely have to be D. I don't even have to do like the calculations or anything. So now let's go and do number 45. So this one's a little bit different. Instead of like making the equation for the line of best fit, you're trying to find the most appropriate, like that's already graphed there. You're trying to find instead the most appropriate line or equation for this data that they've given you. So right away I see, okay, negative slope, because this is looking like a line that has a negative slope. So I know the slope has to be negative. So I can cross out C and D. Then I just have to determine what could potentially be the y-intercept. Well, it's not touching the y-axis yet, but it looks like it might touch it like somewhere above 60 over here. So like positive 60 something maybe. So that would be B.